I thought I might start with a bit of a boring slide, and then we'll get some more interesting ones after that. So to give a bit of context, I think from an EIC perspective, we work across a range of operating companies under CIMIC. And the reason I say that, I guess we've got a good opportunity with the operating companies that we service. And if you look at many of these operating companies, they work across the whole life cycle of an asset, all the way from early design to construction and then into operations and even to finance with specific partnerships. And on a lot of projects, they'll work together. So it gives us a unique opportunity to start to implement some of the stuff we're talking about in terms of lean, in terms of digital engineering, because that really, now that's been one of the barriers, is that segmented way of contracting and segmented way of working. So we talk about the future of construction. Some people would make you believe that this is the future of construction, right? We start to augment all our construction workers, give them superhuman sort of strength, and we'll be a lot more efficient, we'll be a lot more faster. Now, for me, this is a bit of a lazy use of technology, just taking what we've been doing and use the technology to make it a little bit better. Not really improving efficiency, not really using the technology to enable new ways of working. So, you know, I've come from the manufacturing sector, and I guess if you look at a manufacturing facility or a fully automated manufacturing facility, the majority of machines on that manufacturing facility don't look like humans at all. They don't look like humanoid robots. Occasionally some of them do, but I don't believe this is the future of construction. And that's what I'm trying to go through today. We'll start to look to pick that apart a little bit. And if you look at the products that run through those production lines as well, they're no longer made for human assembly. They can be now made differently because we don't have to rely on humans to assemble them together. And this is what we've got to start to look at from the construction side of things as well. So in order for that to happen, there has to be change. Yeah, we've got to need change, we've got to want change. And the construction industry, you know, there has to be a driver for that change or it's never going to happen. And if you go back again to the manufacturing industry 20 or 30 or 40 years ago, there was a higher demand for products. And that higher demand created a change because we just could not keep up with demand. Very labour-intensive manufacturing facilities, no matter how many people you throw at them, you just cannot keep up with the demand. So the option was, go and build 50 of the same type of manufacturing facility, or go and build a few fully automated ones to meet that demand. Some companies went down the route of high labour costs and increasing labour, but the ones that automated are the ones that are laughing now with labour costs going up. So let's start to unpick some of these drivers that will drive. Looks like we've got a bit of a crowd coming on. What's happened here? So let's have a look at some of the drivers that are going to drive the construction industry to change. And the first one, and some of these might have been pointed out, so demand. And you've seen you've seen population growth statistics and where we're going with infrastructure, and we're all experiencing it at the moment. So anywhere on the east coast of Australia, you know, the amount of infrastructure we're currently building is huge, and we're struggling to cope. And this is happening all around the world. So that's one of the key drivers. I guess the second one is resources, and a lot of this was spoken about this morning. So, and this is quite an interesting statistic, that 40% of the current resources that we utilise and energy is consumed by the construction industry. And the sad thing there as well is that 10% of that is gone to waste. It's completely wasted even before it gets used. So most construction sites, there's 10% wastage. That's the average figure that's quoted. So they're two of the drivers. And if you put two of these together, you know, this statistic, I don't know how true that is, it's basically saying we need a whole other Earth to meet the demand we've got in 10, 15 years' time. This is just not going to happen. So something's got to change. Productivity has got to improve. And Martin showed this, took one of my slides, but this is a slide that's commonly shown for the last 15, 20 years, the productivity of the construction industry versus the productivity of the manufacturing industry. And it's quite sad, really, because it's actually declining. It's been declining. And it's quite obvious, right? You go to any construction site and you go to a manufacturing facility and they look completely different. So engineering construction techniques have not changed for a very long time. Some would argue that the technology is not available for construction. I beg to differ on that point. I think the technology's been there, but there has been no drive to adopt and to change. And why is that? Well, mindsets, right? So, you know, if you ask a carpenter on a building site, how can you be more efficient? He'd say, well, get rid of my hammer and give me a nail gun and I'll be a lot faster. But he would never say, or typically wouldn't say, well, give me an alternate joining system so I don't have to use the nails in the first place. Or, give me prefabricated sections so I don't have to, use that nail gun or the hammer. And I guess the other aspect of that, there's no real drive for them to want to change because they're getting paid by the hour, right? If the work runs out, the longer they take, the more work they've got. So there's that mentality of, let's just keep busy. The more we can keep busy, why do I need be more efficient? Because I'm going to run out of work soon. And that's a mentality that happens, I think, across engineering and happens across construction as well. So we never change on this, when we're satisfied with the existing conditions. We're all making money, right? So why should we change? That's the sort of mentality that we're going to break. Because what will happen is, the first person to change is, and this is, I guess, the example that's thrown around all the time, the example of Kodak with digital photography. It's a passing fad, not going to happen. Let's just go and invest in new film factories to start building the demand for film. And they were caught off their feet. And I think that's the issue now, that you can't wait for the change to happen. You just can't move quick enough, especially large companies. So the question's always going to be, who's going to take advantage of this demand versus the need? Is it going to be the small disruptors that are going to come in, or the larger incumbents who are going to be able to see it and have got the investment to drive that change? And this is the other argument, right, that every construction site or every construction project is a prototype. It's basically run like a prototype. They're all different when we start from scratch each time. But if you look at manufacturing, and this is a perfect example of the automotive industry, multiple vehicles, multiple models, but they share 80% of their of the platforms. And for the construction sector, we could say it as well. There's a lot of components we reuse time and time again. So you could be driving a Golf, which shares components with a Bentley. In the old days, every model used to have bespoke components, and this is really the driver behind lean. And that's quite a staggering figure: 80% common platforms, but you still got 2 million options. So you still can be different, but you've really got efficiency across your process. So 5 ingredients that I've come up with, and I'm not an expert in lean construction. I've worked in manufacturing for a long time. I've never formally studied lean construction, and I've been involved in digital engineering and infrastructure for a while. But the 5 key ingredients that I see, firstly, standardisation, and 2 aspects of that standardisation, which I'll start expand upon in a moment. Collaboration, and Martin picked up on that quite well. Collaboration across the supply chain, from the designer to the contractor to the owner to the financer. That really has to happen. Modularisation, so being able to put components together so we're not going piece by piece on our sites. And then that leads to prefabrication, taking stuff off the site and trying to minimise what we do on site that we don't have a lot of control over. And once we've got all that, we can automate. So all of these are sort of linked. And for me, and I'm probably a little bit biased, but I think the secret sauce that brings all these together is digital engineering. And maybe it's because I work in the digital engineering space. But I think it is. Digitising a lot of workflows really starts to drive a lot of the methods we run in lean. And you don't have to be digitised to run lean, but these are one of the big factors that supercharges a lean type working environment. So let's start with standardisation, just conscious of time. 2 aspects of it, like I said, design. Really trying to standardise information workflows from party to party and the way we hand over information from party to party. So we're all speaking the same language. And then on the construction side is our componentry and our equipment. So like we saw with the Volkswagen model. So starting with, I guess, the information side, and from a CIMIC perspective, this is one of the reasons we went down, I guess, finding that we could go and develop our own standards and our own benchmark, particularly around the digital engineering and BIM space. But we looked for an international standard which was starting to be used around the world, and there's no point us coming up with our own standard if our suppliers aren't using those standards and our clients aren't using those standards. So we probably looked towards the British and the BSI standard for 1192, and that's the benchmark we looked at. Now we've been certified because we're implementing that standard on a lot of our projects, not all of them. We've still got a way to go, but we're showing continuous improvement towards that standard. And now that's going to become the international standard, the ISO 19650, which is going to come out soon. But that's allowed us to put a stick in the sand for our suppliers. And the great thing to see now is a lot of our clients, particularly government agencies, are actually quoting those standards. So now we've got some sort of standardisation on the way we talk the same language, move information from segment to segment. And then the second part, CIMIC is a gold member of Building Smart. I think the big important for us is Open BIM. I think Open BIM, and particularly IFC, is just a way we can move information openly, vendor neutral, When we go out to a lot of our suppliers now, we won't tell them what software they need to use or what vendor they should be using, as long as they can hand over information with the right structures and the right geometry, utilising open BIM standards, typically IFC, but that's something that's helped with that translation of information. And then from the components and equipment side, so like we said with the Volkswagen model, trying to look at common elements that we use across all projects, whether it's piles, columns, and start to standardise a lot of those. So maybe we don't have 100 options of a column, we've only got 10 options of a column, and you might have to upsize to the next one. But that gives you that buying power in the market as well, and it allows us then to be a lot faster with our supply chain. Constrain designers to standard elements. So we don't just let our design consultants go willy-nilly, we just say, look, here's our standard library of components, we issue that to you, you work with this as your Lego blocks, and that's what you come back with as a design. You've got flexibility in certain areas, and utilising BIM, one way to provide flexibility is parametric modelling. So we can constrain and say, okay, these dimensions don't change, but these dimensions go for your life. And that can be done within the model using parametric modelling. Once we've got the Lego blocks, then we can start to modularise. So make sure those standard components can form modules, making sure we can prefabricate and easily transport. And that parametric modelling could be set in a way that makes sure that those components can be easily transported to sites, fit within those spaces, and then push to prefabrication. So we really want to minimise on-site works, and the reason we want to do that is we have no control over a lot of those sites. We don't own them. If we own a factory or a manufacturing facility off-site, we've got control over quality. We can pre-assemble, we can pre-test in that facility, we can make sure it works before it goes out to site. So I guess we talk about in the BIM space, you know, build it virtually first and then build it in the real world. We're actually almost saying build it 3 times. So you build it virtually first, assemble it in the factory, make sure it works, and then go out to site, and we know we've got no issue out on site. So we're very quick in deploying out to the site, as we just said. And then once we've got all that, we can implement a manufacturing style of assembly and quality control. So now we start to replicate what manufacturing is doing. But the only way to do that is to try and do as much as we can off-site before we get to those sites, which are all different. And there's always unknowns there, and that's where things go wrong. That's where you get the surprises. So no BIM presentation is complete without the BIM circle, but I've sort of created my own little BIM circle, which was around these elements, rather than showing the typical BIM circle that shows full life cycle. And I think BIM is one of the core enablers to make a lot of this happen. And once we do all that, we start to get examples of what the future construction will look like. And I've showed this in other presentations, but this is a good example of design and construction coming together to build a bridge, utilising new design techniques with generative design to build the bridge, so optimise the structure, and then building it in a way that's prefabricated off-site and then transported to the site itself. So this is where I think the future of construction is, not what we saw in the first video, and probably half the room missed the first video because they were coming from the other presentation, so apologies for that. But I think this is where construction is going. So quite impressive, and this is now finished. So this bridge has been basically 3D printed using 2 welding robots, and has been put in across a canal in Holland, in Amsterdam. So digital engineering, I think, is an enabler of lean construction. And for me, when I say lean, I think it's just being more efficient, because that's what we're talking about here, just trying to be more efficient and just breaking it down to that core word. And I'll probably leave it in that so I don't get the bell in about 10 seconds. So, thanks, David.
A very lean gift.
Oh.
Thank you.
Thank you.